Today we are going to discuss about the topic is bubble sort. This is one of the sorting technique. What is bubble sort principle? What is the principle of bubble sort? Adjacent elements to be compared. Adjacent elements to be compared. This is the principle of bubble sort. And one more important point in the bubble sort is after each iteration, highest element in the list of elements, highest element reached its position. After each iteration, highest element reached its position. Like first highest element, after first iteration, first highest element reached the last position. Second highest element, after second iteration, second last element it's reached its position. So this is the process. This is the process has been repeated. So right, this is the principle of bubble sort, and this is very important point in the bubble sort. Right. So now we have to go and discuss with one example of bubble sort. Right. Now example. I am going to take an array with 5 elements. Right. 10, 40, 50, 20, 30. So there are 5 elements in the array. So in that 5 elements, what happened? 50, after first iteration, 50 has been reached its position. Next 40 has been reached its next position, next highest. 30, 4, 20, 10. So this is the process. So here, so this is the array. Now simply we can call pass, not iteration, pass. Suppose pass 0. Pass 0 contains 4 iteration, because here pass 0, totally 5 elements are there in the array. 5 elements means 4 comparisons are possible. Each comparison we can call one iteration. So after one pass, so not previously we discussed iteration, not iteration. After one pass, highest element reached its position. So here pass 0, 4 comparisons are possible. Pass 1, 3 comparisons are possible. Pass 2, 2 comparisons are possible. Pass 4, 1 comparison is possible. Now pass 0, 4 comparisons. So we can call this is iteration 1. Suppose iteration 1, 10, 40, 50, 20, 30. So here first element, second element has to be compared. In iteration 1, first element and second element has to be compared. If the first element is highest compare with the second element, then we need to go with the swapping. First element is highest, compare with the second element, then we need to go with the swapping. But here the first element is least, compare with the second element. So there is no need of swapping in iteration 1. Now iteration 2. What happened in the iteration 2? Second element and third element has to be compared. 40, 50, 20, 30. These two elements are compared. Now again 40 is least, compare with the 50. So there is no need of swapping. Next, go to next iteration. Now iteration 3, third element and fourth element has to be compared. That means 50 and 20 are compared. So what happened? Now first element, that means 50, has been highest compared with 20. Then we need to go with the swapping. Swap. 40, 50, 20, 50 and 30. Now last iteration. Now these two elements are compared. Now 10, 40, 20, 30, now 50. What happened? After completion of one pass, what happened? Highest element is reached its position. Now totally how many comparisons? This is first comparison, second comparison, third comparison and fourth comparison. I means 5 elements are there, 4 comparisons are possible in one pass. First pass. So highest element is reached its position. Now we need to go with the next pass, second pass. Pass 0. After pass 0, what are the elements? 10. After pass 0, then what happened? The elements are 10, 40, 20, 30 and 50 is sorted. 50 is sorted. Now what happened? Here first element, second element has to be compared. So this is, we can call iteration 1. Suppose iteration 1. 10, 40 compared. So 10 is least, compare with 40, not need of swapping. 10, 20, 40, 20, 30. Now 40, 20 are compared. 40 is highest, compare with 20. So then go with swapping. Swap. Then 10, 50 is already sorted. 10, 20, 40, 30, 50 is already sorted. Now 40 and 30 are compared. So this is the previous iteration. I am going to rough this one. Now 10, 20, 30, 40, 50. According to the rule, all elements are sorted, but according to the pass 1, 3 comparisons are possible. 1, 2, 3 comparisons are possible. Pass 0, 5 elements are there, 4 comparisons. Pass 1, pass 1, unsorted elements are 4, 3 comparisons. Right? So after 3 comparisons, now 40 and 50 are sorted. Originally 10, 20, 30 are also sorted, but we need to go with another pass also. Now pass 2. Pass 2, 10, 20, 30, 40, 50 are sorted. Now here only 2 comparisons. One is iteration 1. 10, 20 are compared, no need of swapping. Iteration 2. 20, 30 are compared, no need of swapping. Now 10, 20, 30, 40, 50. So these 3 are sorted. And these 2 are also sorted, but we can call directly, we can't call sorted, unsorted. Again we need to go with one more pass. One more pass. Last pass. Right? Now 10, 20 are elements, 30, 40, 50 are sorted. Only one iteration, these 2 are compared. Now finally 10, 20, 30, 40, 50. So this is completely sorted array. Now before going to write the program, so we are going to write one logic for bubble sort. Find the logic for bubble sort. Logic for bubble sort. Pass 0. 5, suppose 5 elements array. 5 elements array. So then 4 passes are possible. Pass 0, pass 1, pass 2 and pass 3. Pass 0, total how many comparisons are possible? 4 comparisons. Pass 1, 3 comparisons. Pass 2, 2 comparisons. Pass 3, 1 comparison. That means 5 elements, 4 passes. Suppose 100 elements, 99 passes. So this is the process to find the logic of bubble sort. In the next class, we have to discuss about to write the bubble sort C program.